I'm going to begin with hypervisors and virtual machine managers. So what is the difference between a hypervisor and a virtual machine manager? The difference could be nothing, or the difference could be everything. Some people use the term hypervisor very broadly. They use it to refer to any of the software that is used to manage virtual machines. Others will differentiate between the two terms in this way. A hypervisor does not need a host operating system, while a virtual machine manager, or VMM, requires a host operating system such as Microsoft Windows, Apple OS X, or a Linux operating system. Well, the hypervisor can operate as its own operating system. With that covered, let's talk about some of the components of virtualization. First up is the virtual desktop. A virtual desktop is a virtual machine, or VM, that functions as a desktop. Now, any modern operating system can be run inside of a VM desktop. Multiple virtual desktops may be hosted on or from a single host system. Then there are virtual servers, which surprisingly is a virtual machine that functions as a server. Any modern server operating system can be used in a virtual server environment. Multiple virtual servers may be hosted on or from a single host. Guess what? There are then virtual switches, firewalls, and routers. These are virtual machines that fulfill the functions of the switch, firewall, and router. Virtual firewalls and routers are particularly effective when they are combined with virtual network interface controllers, or virtual NICs, and virtual switches to create virtual networks. Speaking of virtual networks, an important consideration for when designing a virtual network is how that virtual network is going to pass traffic to remote networks, or networks outside of the host system. Virtualization by its nature leads to either an open and highly scalable network or a closed self-contained system. It is possible to create a completely self-contained network with all of the virtual components and never have network traffic leave the host machine. But if there is a desire or need for that network traffic to pass beyond the host system, then that function needs to be specifically granted. A connection must be created between the host system's physical NIC and the virtual networking equipment to allow network traffic to pass through the physical host system. Next up, software-defined networking. Software-defined networking, or SDN, is the process of allowing the administration and configuration of a network to be done dynamically. With SDN, the administrator uses a front-end program to make adjustments to the network. This program sends the instructions to the networking equipment, which is then reconfigured to perform as the administrator desires. SDN can allow network administrators to dynamically adjust network performance without the need to log into each individual device that needs to be adjusted to achieve the desired performance. SDN is considered to still be an emerging technology, but SDN also works well for virtual networks and cloud computing. To begin with justifications for storage area networks. There have been several factors that have led to the increased demand for data storage. One of them has been the dramatic decrease in the actual cost of data storage. It actually costs us less now for storage on a per gigabyte basis than it has in the past. What has happened is that as the cost of storage has decreased, the demand for storage has increased dramatically. Businesses are now generating and analyzing huge amounts of data in an effort to create a competitive advantage. Think big data. I'm sure you've heard about big data recently. Or this increase in data collection has led to an increased demand for storage capacity. Another factor is that as the demand for data has increased, It has needed to be more available, which means that there has been a need to be able to access that data from anywhere, and the accessibility is needed to be increased as well, including from non-standard devices. A storage area network, or SAN, can be a solution to the need for both storage capacity and high availability. There are several advantages to the storage area network. First off is scalability. The amount of data that is being generated today is huge. This has led to a need to store that data. The SAN is more scalable than other options. As your storage needs increase, the capacity of the SAN can be easily increased to meet that storage need. Then there's data availability. The demand has also increased for that data to be available at any time from anywhere, and a SAN can play a vital role in creating that accessibility. One of the most popular implementations of a SAN is to deploy it as part of a cloud computing solution. This increases the availability of that data that's being stored on the SAN. And finally, there's optimization. As the requirements to store data are removed from application servers, those servers can then be optimized to run those applications much more efficiently. At the same time, data storage is also optimized. It's time now to discuss some SAN technology. The storage area network, or SAN, and the network attached storage, or NAS, often get confused with one another, but they are different. The SAN is an actual network of devices that have the sole purpose of storing data efficiently. On the other hand, the NAS is a specifically designed network appliance that has been configured to store data more efficiently than standard storage methods. The difference is that a NAS is a data storage appliance that is placed on a network, while a SAN is a network of data storage devices. It is not uncommon for a SAN to contain multiple NAS devices. With all of that data storage capabilities, several technologies have been developed to ease the transmission of that data. The first one that we're going to discuss is Fibre Channel, or FC. Fibre Channel is a high-speed network technology that was originally developed to operate over fiber optic cables only. Since its introduction, the standards have been modified to allow the use of copper cabling in conjunction with fiber optic cabling. Fibre Channel is commonly used to connect to SANs. When Fibre Channel is implemented, it uses the Fibre Channel Protocol, or FCP, as its transport protocol to transmit SCSI commands. So it transmits small computer system interface commands to storage devices, as in the NAS appliances. So a SAN implements FCP as opposed to TCP as its transport protocol when Fibre Channel is used. Another technology that was developed was Internet SCSI, or iSCSI. iSCSI is an IP-based networking standard that is used to connect data storage facilities and SANs. iSCSI allows for SCSI commands and processes to take place over longer distances than the original SCSI implementation. Jumbo frames are also allowed within the SAN environment. Jumbo frames allow for greater throughput of data by allowing up to 9,000 bytes of data to be in a single frame. This can greatly increase the efficiency of a SAN. As a comparison, the standard frame on an Ethernet network can only be a maximum of 1,500 bytes. I will begin our session with a discussion about cloud classifications. Cloud computing is where the resources on the network are not actually physical in nature. They are provided to the end user virtually. Cloud computing can lead to a very fluid and dynamic environment, as the required resources are normally only provisioned or supplied as needed and are decommissioned or shut down once their use is done. Most often, these virtual resources are not owned by the company or user that uses them, but are provided by a service provider. While cloud computing is highly configurable and changeable, it does have some basic structures that are used in the classification of the type of cloud that is in use. The first classification of cloud computing that we're going to talk about is the public cloud. This is where systems can interact with services and devices within the public cloud and on public networks, like over the internet, and possibly with other public clouds. The public cloud is where the services that are provided are not just provided to a specific user, but are open for the public to purchase and use. Then there are private clouds. This is where systems only communicate with services and devices within a specific private cloud. A private cloud is essentially just that, private. The only users who have access to it are ones who are authorized to use it. The cloud classification can be hybrid. It can combine aspects of both the public and private clouds. And last up, there are community clouds. This is where cloud services are used by private individuals, organizations, or groups that have a common interest. Now let's move on to different types of cloud computing. Because of the nature of cloud computing, it is very configurable to the needs and desires of the purchaser of the cloud services. Purchasers have many options beyond the type of cloud services that they want to provision. They must also determine what type of service they are going to require, from the most basic of services to the most highly complex of services. The purchaser needs to have a plan going into cloud computing in order for it to be efficient and effective for them. So now let's move on to some of those services that cloud computing can offer. First up is software as a service. The end user purchases the rights to use an application or software without the need to configure the virtual servers that will deliver the application to them. It is usually delivered as a web app or web application, opened and used from within a web browser, but not always. If you have a subscription to Microsoft's Office 365, you are utilizing software as a service. Then there is platform as a service, or PaaS. The user is provided with a development platform for the creation of software packages without the need to configure the virtual servers and the infrastructure that delivers it. You are essentially renting server or computing power in order to develop your software packages. PaaS is more complex than software as a service. And finally, we have infrastructure as a service. This is where the end user is provided with access to virtual servers, configurable by the customer, and other virtual network resources. Their infrastructure is actually virtually provided to them. This creates a highly configurable environment in which customers can create the resources and the performance that they require. The end user supplies the software that's going to be used on the IaaS network, or they purchase it as an additional software as a service. As you could have guessed from that last statement, it's not uncommon for the type of cloud computing being utilized by an organization to be a mix. Some departments may rely upon and use infrastructure as a service, while the development team will only utilize a platform as a service. Part of the advantage of cloud computing is that the purchaser only needs to initialize and pay for resources as they are needed. In a private cloud situation, it is possible for an organization that is using it to actually own the cloud resources. if they do own the cloud resources, they may have it on site, or they may pay to have those resources hosted off site. That way they can offload the maintenance cost of maintaining those resources.